Hello, am I audible?
Yes, ma'am. Audible.
Okay, thank you. Good evening, everyone. I'm Shefali Agarwal and I am a PMRF scholar at IIT Madras. So, this is our 7th TA session on the topic of advanced concrete technology. So, in this week, you might have studied about the mineral admixtures, completed the mineral admixture part. So a little overview, if we talk about mineral admixtures, they are like when we have a different type of supplementary cementitious materials or which can behave as a cement alternate or fine aggregate alternate that we are calling as mineral admixture. So if you see from this ternary phase diagram, based on the amount of oxides, different oxide, we are distributing our mineral admixture in different ways. Okay, so naturally available mineral admixture which are commonly used in our concrete are GGBS, means slag, fly ash, two type of fly ash, F type and C type, and silica fumes. Other than this, if we talk about further different type of mineral admixture, firstly we will see how we are, what are the different methods through which we can determine the durability. So we know we have two aspects. First is mechanical strength, second is durability. So mechanically we are normally calculating our compressive strength of the concrete, but when it comes to durability, what all tests which are important is firstly is the how chloride penetration. So that is done by RCPT test or migration test, and sorry uh, so if we talk about durability, we have test, first important test is RCPT, which is rapid chloride penetration test. In this we have a cell and we will pass a charge through it and see how chlorides will penetrate from one end towards the other end. And then we have conductivity test. So this is almost similar to the RCPT test, and other than this we have surface permeability test apparatus. It will look like this. Then there are other water based permeability tests. So this is chloride permeability, this is water permeability, and then sorptivity means how much moisture is getting absorbed from the bottom of our sample. Then OPI, oxygen permeability index, so it will tell us about the permeability or pore structure of your material. So these are mainly all permeability tests which will help us determine the durability of our concrete structure with different mineral admixtures. So after this we have what is the influence of different SCM on these durability properties. First is on chloride penetrability. So through surface resistivity, if we check, if we are increasing our SCM if we are increasing our SCM replacement level, our resistivity is also increasing. That means our structure is getting less porous or our permeability is decreasing, which will increase the resistivity of our system. Other thing is total charge passed. So same way, if your permeability is decreasing or your concrete is getting more compact, then there is chance the total charge passed or the permeability will start decreasing. Okay, And next is influence on water solubility. So same way, if you see, adding SCMs, uh, replacement, increasing the replacement level of SCM will decrease the solubility index of your system at mostly at 90 days, but at 28 days is almost similar. And same way, it is slope of our solubility test, that also will decrease at mostly at 90 days. So why it is happening at 90 days and not at 28 days? Any idea? So if you remember our if you remember this graph, when we are adding SCM, our pore structure is decreasing or porosity is decreasing, but it will happen after several days. It won't happen within initial days. So replacing our cement with the concrete, uh, replacing our cement with the different SCMs, it will decrease the porosity, but it will have a long term effect. It won't decrease the porosity within 28 days. Even our strength value won't gain strength within 28 days. The strength gain will be maximum in 90 days. So it will be like extended testing when we are using SCMs. So next thing is, based on durability test, how we can rank our binders. So if you see this scale 1 2 3 4, so this table is only of 28 days value. Same way, we have a similar table of for 90 days value, which is in the PPTs. You can check that thing. And here, if you can see, we have 4 properties: chloride penetration, water solubility, gas permeability, and CO2 penetration. So with the addition of OPC, slag, fly ash, and different fly ash C type at different percentage of replacement, how we will rank these type of concretes. Other thing, other these are the basic SCMs which are being used in the concrete system. Now, along with these SCM like fly ash, slag, and silica fume, we have some other SCMs mainly which are found in India, like rice husk ash. So it is a very highly reactive porcelain obtained by controlled calcination of rice husk. So if you see in India, mostly we are agricultural area, so we have a lot of rice husk, and this is the one type of waste material which can be used for concrete replacement. So these are the different properties of our rice husk ash and physical and chemical property. So this is how exactly a rice husk ash look like, and it's a SEM analysis figure. Same way, another type of SCM is metacolloid. So it is obtained from clay, mainly kaolinite clay, and it is obtained by calcinating this clay at a very high temperature of 740 to 840 degrees Celsius. And after this, and this burning should be continuous, and generally it has a formula of AS2. Okay. And further thing is, when this AS2 will react with calcium hydroxide present in the cement, it will form additional CSH plus another compound which is C4AH30. Okay. So since this is not a byproduct like rice husk ash from industry, it is little expensive as compared to our previous SCMs. Okay. And further with how this is behaving in concrete, you can see here if we are increasing the replacement level, our compressive strength value is increasing with the addition of metakaolin, and its behavior is almost similar to that of silica fume, right? Because silica fume also is very fine particle, and same way metakaolin will also be very fine particle, not like fly ash and rice ash. They will have some what we'll say a grainy particle, but these will be like fine particles which will not only act as a binder, but also will be as a fine particles in the concrete system. And few advantages of metakaolin as SCM is it is highly reactive and high early strength, better chloride resistance, increase in chloride binding capacity of HCP due to higher alumina present in the metakaolin, unlike silica fume. So this is another type of SCM. Next is using limestone as an additive. So currently you might have heard about LC3 a lot. That is kind of trending SCM being used. So how limestone can be used as in the cement industry? See, in OPC itself we have almost 55% of limestone. Not every OPC, but in India normally we have 5% of limestone present in our OPC system, and in ternary system we have approximately 6 to 20% of limestone cement blends. So what will happen if we increase the limestone addition? Our performance or strength will reduce, but when we are making low grade concretes, if we are preparing low grade concrete, for that it will be a good alternative. So if we talk about ternary blended system, so we can have limes, we can have our normal SCMs, cement, and third thing is we can have limestone in it, which will act as a binder. So this is how evolution of hydrate phases in ternary system look like. So this graph is similar what we have seen in the previous class also, how with time our hydration products are increasing and hydration products are changing and different things are increasing. Do you have any question? Somebody raised hand. If you have any question, you can unmute and tell. Okay. So what is happening when we are using ternary system? We have the ettringite is getting stabilized, and there is an increase in carboaluminate phases, and portlandite is decreased, which will increase the amount of CSH and CSH in the concrete system. So our CSH will increase, however our calcium hydroxide will decrease, which will decrease the alkalinity of the concrete system. Okay. Also there want our ettringite will be stable, it will be constant almost. And other thing is how we can classify a limestone effect in cementitious system. If we talk about physical effect, what exactly limestone is doing, it is just acting as a filler effect, it's not a binder effect. So if it is as a filler effect, it will improve the packing or reduce the capillary pores inside the concrete system. And with addition of calcium, more calcium is added, what will happen, it will cause the nucleation of CSH on limestone surface. And also with the increase in calcium, with the increase in calcium ions, what will happen? It will accelerate the C3s hydration. Okay. And other thing is increase in carbonates. So increase in carbonates will result the formation of HC more than MC. So these are ettringite formation. So it will increase the formation of HC and MC, and it also stabilize the formation of ettringite in our concrete system, cementitious system. Next thing is, when we are adding limestone, we and sorry, this is next type of SCM, limestone calcined clay cement. So in this, what we are adding, as we talked about ternary blended system, we are telling it is clinker plus NaSCM plus limestone, right? So in this case, Lc3 SCM is our metakaolin. So it will be clinker plus metakaolin plus limestone. That is called as Lc3 system. Okay, limestone calcined clay system. So in this system, how Lc3 will affect the different properties of the concrete. If you see from compressive strength, calcined clay and metakaolin both are equal or not. You can say it can be equal. It can be equal because metakaolin is formed by calcinating clay at 800 degrees Celsius. So metakaolin and calcined clay are same only. So more the clay content, or more the calcined clay content, more will be a strength value. If you can see from here, it is like if we talk about only 28 days value. So if this is a graph for 28 days value, more the clay content, more will be a strength value. However, it is not much difference, like it's not going from 20 to 40, but still the change in increasing in clay content will increase the strength value of our system. Also, if you see in here, if with time how ettringite is changing. So as we told, as we said that in ternary system our ettringite will be in the stable format. So here also you can see initially 7 to 14 days it is fluctuating, after that it is getting constant. Okay. Other thing, these are the physical or mechanical properties. If we talk about durability performance, so first is PC, other is metakaolin, other is Lc3 means metakaolin plus limestone. In that case, what is happening, our chloride content value is decreasing with depth. So this is our diffusion coefficient graph, calculation of diffusion coefficient. So chloride content with depth, if you see the slope is very constant, that means there is not much penetration of our chlorides to lower depths in the concrete system. Other is porosity. So same way, if you see porosity with the smaller radius pores are more as compared to bigger diameter pores. That means that means your pores are being filled by limestone, and that's why your porosity is decreasing. Same way, if we talk about other things like strength value, comparing fly ash and Lc3. So you can see from here your Lc3 have a better, or almost have a better compressive strength as compared to fly ash with 30% replacement. Same way, this is also compressive strength of LC3 and fly ash as compared to OPC. So your LC3 have a better performance from initial stage to later stage. Other thing is how microstructure is developed in different system. So here if you see, it is surface surface resistivity or conductivity you can measure. So with time your conductivity is decreasing, that means your resistivity is increasing, which is again the effect because your pore size is decreasing, right? If your pore size will decrease, what will happen? Your resistivity will surface resistivity of concrete will increase. Other thing is calculating formation factor. So this is a simple way. Instead of calculating all the durability factors, we can calculate formation factor, which will be an easier way to characterize our blended system. So if you see here also, your formation factor for LC3 is very much higher than compared to your fly ash or your other type of concrete system. So comparing your formation factor with porosity, so it is a almost linear graph, decreasing in a decreasing way. Next thing is comparing the surface resistivity values at different days. So if we talk about M30 concrete, M30 concrete itself, in case of LC3 you have a very high surface resistivity as compared to OPC, even even at the 28-day strength or at the 365-day strength value. So LC3 have a better properties as compared to OPC and fly ash. Here we are doing comparison only with fly ash. Same way, same thing has been done for RCPT test. So here if we do RCPT test, the charge passed in LC3 system is very low, so almost 100 or something. So this less charge pass means the chlorides are not able to penetrate from one end to another end. That means your pore structure is very refined. Same way we have done sorptivity index, oxygen permeability index, and if we talk about lab and field specimen, how it is being compared and which will have a better value or which will have a better uh, results. We see here we have almost if we talk about trend is almost same in terms of field and lab specimen, whether it is LC3 or PPC. However, our values are very much different, but trend is almost same. Like if diffusion coefficient is very low in case of LC3, on fields it's low in lab also. Same way, if it is high in field, it is higher in lab also. So trend is same, but the values are different. So that is all about LC3 system. Next, if we talk about another type of SCM, we have sugarcane bagasse ash. So if you remember, we had rice as cash. Same way we can use the sugarcane bagasse ash. So this sugarcane bagasse, it is being burnt or calcined at a very high temperature, and ash is collected, which is called a sugarcane bagasse ash. So this is a type of new type of SCMs which are getting popular in India because of more availability of these type of raw materials. So this is the microstructure of sugarcane bagasse ash. We have fibrous particles, some irregular particles, some spherical particles, and some prismatic particles also present in the bagasse ash. So if we talk about a raw baguette ash, it will have three type of particle: some burnt particles, some fine particles, and some very fine particles. Okay, based on this microstructure, if you see, and how it is being performing in concrete. If we talk about strength is being increased. If we talk about charge past or RCPT test, it is charge past will have very low value when we are using baguette ash, and same way depth of penetration for chloride, that is also reduced when we are increasing the replacement level of our baguette ash. Lastly, we have geopolymers. So geopolymers are some aluminosilicate materials that are activated using alkaline solution. So these are few examples of our geopolymers, like aluminosilicate material, calcined clay, GGBS fly ash, and the activators can be potassium hydroxide, sodium hydroxide, some silicates, or anything. So what is happening, if you see here, we have aluminous silicates, then we have alkali activators. So when we mix both of them, they are we do mixed design curing, and we have different type of results coming out from these type of geopolymers. So that's all you might have studied in this week 7. If you guys have any doubt, you can ask, otherwise we will see some questions. You can type in chat box also. Any doubts? Okay, then we will see few questions. First question is, state true or false. Post structure densification in cement mixes with SCM are more significant in the later age hydration, more than 28 days up to 90 days, due to pozzolanic reaction. True or false?
True.
True. Correct.
True.
That's all we were talking about. When at later stages there is more pore densification, and because of that is because of later age hydration. Okay. Next question is, RHA is a good pozzolan when. So RHA, rice husk ash. It is a good pozzolan when it is field burnt, controlled burnt, or used raw, or rich in crystalline
B.
P, controlled burning. Okay. Anybody else who thinks some other option is correct? Okay, your answer is correct only. When it is controlled burning, then we can have a uniform structure of our ash, and it will behave as a good pozzolan in that case. Otherwise we will have different type of particles in it, and there are chances of it to agglomerate or not mix properly in the cementitious mix. The main reaction of metakaolin with the CH forms portlandite, ettringite, C4AH13 plus CSH or AFM.
C.
C. Correct. So we are telling when we are adding metakaolin, when metakaolin reacts with CH, it will form additional CSH and a new product C4AH13. So this is the formula of metakaolin, AS2 aluminous silicate. Okay. Choose the correct statement with respect to the properties of metakaolin when used as an SCM. High reactivity as SCM, higher early strength, better chloride resistance, increases in chloride binding capacity of HCP due to higher alumina, or all of the above.
All of the above.
Yeah, correct. So when we are using metakaolin, it will increase the reactivity. Also, early strength will be increased. Will have a better chloride resistance. Increase the chloride binding capacity of HCP due to higher alumina. So all options are correct. Next question is, pozzolanic reaction is lime consuming, pore refining, higher heat of hydration, or slower reaction compared to C3S hydration.
A. Lime.
A. Okay, lime consuming. Any other option do you think is correct?
C.
C. Okay.
D. D.
D. So answer correct are, it's lime consuming and pore refining and slower reaction compared to C3's hydration. So higher heat of hydration is not correct, because higher heat of hydration means you have a very high content of C3A. If you have higher content of C3, then only you are telling you have higher heat of hydration, C3 or C3S. But in case of pozzolanic reaction, nothing of that sort is happening. You are not increasing the content of C3 and C3S. Therefore, there is no higher heat of hydration. I hope that's clear. Okay, next question is, rice husk ash calcined at very high temperature more than optimum results in increase in crystallinity. Higher crystallinity results in increased reactivity of rice husk ash. A is true, B is false. A is false, B is true. Both A and B are false. Both A and B are true.
A.
A. Okay. Anybody else who think any other option is correct? Okay, correct. A option is correct. So rice husk ash, when calcined at very high temperature, it will increase the crystallinity. However, more crystallinity doesn't mean there is increased reactivity of rice husk ash. Next question is, large hollow spheres with solid spheres inside them are called cenospheres. It is true or false? true. Okay. So if we talk about spherical particles, as we have seen in our one of the SEM graphs, so when we have small hollow spheres with entrapped gas, those are called cenosphere. We have large hollow spheres with solid sphere inside, they are called piezospheres. So we are talking about cenosphere, those are mostly small hollow spheres. So the answer is false. Okay. Next question is finely grind limestone mainly act as hydraulic binder, filler plus chemical stabilizer, alkali activator or pozzolanic material.
D. Filler plus chemical.
Filler plus chemical stabilizer.
D.
D. Pozzolanic material.
D.
D. Okay. So normally limestone will act as a filler, not pozzolanic material. For pozzolanic material we have metakaolin that will act as a pozzolanic material. Limestone will just act as a filler inside the concrete system. Okay. LC3 cement consists of clinker, calcined clay, limestone and gypsum, slag, fly ash, silica fume. What is the additional thing we are adding in
A.
A? Correct. So gypsum is the additional gypsum we will add in LC3 system, which will what it will do? Stabilize the attringite. Okay. The most important factor governing LC3 performance is particle size of limestone, kaolinite content in clay, gypsum content, curing condition.
C.
C. Gypsum content. Anybody else who thinks some other option is correct?
B.
B. Yeah. So correct option is B. Kaolinite content in clay. So if you remember, we have seen many graphs where we are telling increasing clay content, how your strength value is increasing, and how your let's say charge past is decreasing. So the main important factor is kaolinite content in clay. Next question is optimum processing for SCBA. CBAs are Burgess ash. Is burning at higher temperature, agglomeration with lime, grinding to cement fineness, or using raw as collected. So in case of Burgess ash, it is
C.
correct. It is important to grind it to the cement fineness level. Geopolymers are produced by activating aluminosilicate materials using lime water, alkaline solution, gypsum or sulfates.
D. C. C.
See, okay. So in geopolymers we talked about two things. One is aluminosilicates and others are activators. So normally our activators means our alkaline solution actually. So answer is B. So if you remember, we talked about potassium hydroxide and sodium hydroxide being used as activator. So that's why answer is B. A limitation of geopolymer technology is it have poor strength, it use hazardous alkaline chemical, poor durability, low fire resistance.
B.
B, correct. So using chemicals is the one of the major limitation of geopolymer technology. Aluminosilicate and kaolinite clay get activated when calcined at a temperature of above 1500 degrees Celsius, between 1000 to 1500, between 740 to 840, or between 540 to 740.
C. 740 to 840.
C.
740, correct. So in metakaolinite we have seen we are calcining it at a temperature of 740 to 840 degrees Celsius. Choose the correct option from the below. Limestone addition to systems containing aluminates result in the formation of monosulfates. Ettringite converts to monosulfate in the presence of excess alumina. Ettringite gets stabilized with the addition of limestone. Density of ettringite is more than that of monosulfate. Any idea?
A, B,
A and B, okay.
B. B. Correct.
Which one?
D. D.
D, okay. So answer is actually B and C are correct option. Let's see why it is like that. First is limestone addition to system containing aluminates result in the formation of monosulfates. So it's not the addition of limestone which is forming monosulfate. It is because of addition of metakaolin. Okay. So this is wrong. Next is ettringite converts to monosulfates in the presence of excess alumina. So this is correct statement. Ettringite gets stabilized with the addition of limestone. Correct. Density of ettringite is more than that of monosulfate. So this is false statement we have, because monosulfates ettringite will be like needle like structure, right? And monosulfate won't be needle like structure, it is like a agglomerate kind of thing, like a fluffy kind of thing. So it will have more density as compared to ettringite. Okay. Next question is, in the sugarcane bagasse ash, the fibrous particles are due to reactive silica particles, inorganic, organic, or crystalline.
Inorganic.
Inorganic or organic? So normally these fibrous particles in our if we see like this, these fibrous particles are actually organic particles. Okay. So zone 3 in the electrical conductivity test measurement results indicates the setting of waste. So hence the graph will show an upward increase, parallel to the x-axis decreases downward. So there were few tests at the last of the PPT. I think I forgot to cover that in the initial thing. So I will cover that in the next lecture. So these questions are based on that. So I will tell the answer myself only. Normally it will decrease downward. So in electrical conductivity test, if it is indicating the setting, indicate the setting of the paste, what will happen? Your conductivity will decrease. So more the setting, your resistivity will start increasing and your conductivity will decrease, mainly in zone 3. This is IS. IS 1727 specify which test for pozzolanic activity: fraternity test, lime reactivity, strength activity, or conductivity.
A.
A. Okay. IS 1727 will tell about lime reactivity test mainly. Okay. Okay. A concrete mix design for coastal exposure requires improved chloride resistance while keeping the clinker content low. The most suitable binder system is OPC, 30% fly ash blend, LC3, or Bagasse ash. According to you, what do you think will be a better option? C, LC3, correct. So we have seen all the result from LC3. It is improving the chloride resistance by decreasing the pore structure, decreasing the permeability. All those durability properties are better in LC3 system as compared to OPC and fly ash system. So the last question is, pozzolanic activity of a new batch of SCBA needs to be quickly assessed on site. Which test is most practical for early stage evaluation? Fraternity test, strength activity, lime reactivity, or electrical conductivity? So since we didn't cover the test, so I will tell the answer. It is mostly electrical conductivity test for site. Since it is about pozzolanic activity on site, we will do conductivity test because these three are mainly lab based test. Okay, so that's all for this week. If you guys have any doubt, please let me know. If you have no doubt, you can leave the class. Please show the 19th question. This one. Okay, thank you for joining the class. If you have no doubt, then I will end the class.